So this is another follow-up video on a structure where we have certain requirements which are captured using a parametric diagram, and we are looking at some of the value properties and checking if those values are less than some threshold that we have specified in requirement. So if you like to see how we build this structure, you have to go and look at an earlier video that says ATM-PAR with simulation or something like that. So what we are doing in this video is to try to address a situation where we are again building something, in this example an ATM, a very oversimplified version of that, with two components, computer unit and a display. Each of these components have a single value property. In display you see two, but we are only using one value property that says weight of that particular component, and we are calculating the weight of the overall system, that is ATM, as a sum of these two things which are captured by a constraint block, and you may see it in the parametric diagram that is shown on the screen. So we have done two earlier videos, or made two earlier attempts where we had this structure with the parametric diagram supporting the relationship between these value properties. And in the first one, we provided user-defined values to these weights, individual weights of these components, and the parametric diagram would calculate the total weight, check against the requirement or the constraint that we have in the diagram. And that's how we created those instances with user-defined weights to these components, put all of them in an instance table, and we can also create new instances and evaluate those new instances in an instance table. So that was the the video we have done before. In the second video, we assume that these weights, which are the weights of these two parts, computer unit and display, are random variables. So there is a known probability distribution with min and max values. Again, we use the uniform distribution, therefore we had this min and max values, and we were, during simulation, drawing numbers from that interval, assuming that all the values are equally likely, and using those as the weights of these individual components and calculating the weight of the ATM machine by adding those things. And then we had a histogram that would display those generated values, and we ran the multiple simulations to generate multiple samples that would be displayed on a histogram. Now in this video, what we are trying to capture is a slightly different situation where we have some specialized blocks, derived blocks of these computer units and displays. So somebody goes to the, let's say, market and identifies that there are two of these computer units, or two types of computing units are available out there, and they have specific value properties which will be described or captured as default values of their value properties, the new blocks that we are going to add. And similarly, assuming that we have two different types of displays which are available with their known weight, so we are not stochastically drawing those values. We are not asking users to provide those values either runtime or by creating instances offline and then evaluating those instances against our parametric constraints. So this time we would like to add a little more structure, trying to capture this reality that I've just described. So let me just zoom in to the part where we will be working. So assuming that we have new information that tells us that there are two types of CPUs which are available in the market, I'll just call them CPU 1 and CPU 2. And these are derived versions, or these are things which are specialized blocks of this computer unit. So I'm just creating the generalized or generalization relationship between CPU 1. So CPU 1 is a type of a computer unit, CPU 2 is another type of a computer unit. The next thing we are going to be doing is to double click on the CPU 1, look at the properties or attributes, and see that the weight attribute of the computer unit, which is the the base class of this, or base block of this new block that we are introducing, CPU1. So it has inherited this wait CPU property from it. So what we will do is we'll redefine it, and as part of this redefinition, we will say, okay, we know that there is this CPU1 available, and it is 10 kg, so its weight is 10 kg. So now we have, CPU1 with this redefined weight of CPU, and it has a default value of 10.0 kg. We'll do the same thing with CPU2. Again, double clicking on it, properties, redefine this, it's inherited, and now we can put, let's say, 6.8 kg. And that's it. Let me close it. So now we have these two CPU1 and CPU2 blocks with their specific values for these weights are already given. Similarly, we are going to be doing the same thing with display. So let's say we have two types of displays. Let me just give them some meaningful names. So this is, let's say, high res display, and we have another which is a low resolution display, and we again have the same relationship between these new blocks that we are bringing in and the block that we already have there. Let me make it a little larger, rearrange these things. Have more space. Okay, so now we go back to these new blocks. We go to high resolution display, look at its properties. We see the two value properties inherited by it, because that's what we have in our display block. We would inherit both of them, and let's say the weight, when we redefine it, we give it a value 3.5 kg. We also redefine the resolution, and we simply keep it as is. We are not giving it any default value. Let me say close. We do the same thing with low resolution. We double click, go to properties, redefine the weight, give it, let's say, 5 kg weight, redefine the resolution property, and that's it. We say okay, close. So now we have a situation where we have an ATM machine that we are building with two parts, computer unit and display. They can be seen as black box definitions. We do not have all the information for their value properties, and now we are bringing in these white box definitions of these CPUs which are available in the market. So these are actual physical things which are available with their known weights and all the other attributes. And now we would like to build our ATM instances, which would be some combinations of, so I may have CPU1 paired with high resolution display, I have CPU1 paired with low resolution display, and so on and so forth. So we'll have 4 possible combinations that we can generate with that, and then run all those 4 possible combinations through our parametric diagram, and see which of those combinations would satisfy our requirements and which would not. Now these possible instances can be created automatically if you are familiar with the trade study pattern available. But what we will do in this example is just create a few of those combinations manually, and then have an instance table which would record all those things, and we would evaluate those instances for against the requirements that we have, or the constraints that we have added to our parametric diagram. So let's do that. So the next thing we are going to do is to create an instance. We are going to use this tools and create instance method, and over here we are going to select the CPU. So here is the CPU. You see that there is this type computer unit. Click on it. We would like to select CPU1 because that's one type of CPU. We would look at its value property. We would like to have it, and you see that the value property 10 is what the block has in it, and we already see that. Similarly, we are going to have our display. We click on this display down there and decide which display. So let's have a high resolution display selected, and that's it. That's all we want in our instance that we are creating. So we say next, and we just say finish, and it will show you a representation of this instance that has created. We are not interested in having this thing. It's already there in a containment tree. Here it is. So you see this instance. So what we are going to be doing next is to create an instance table where we are going to display this instance, and perhaps create a little more instances and put them over there as well. So let me have a separate package which has the instance table and all the instances. So instance table, and we are going to also put the instances in the same package. So let's put it there. Right click, say create a diagram, instance table, and here we have an instance table. We'll simply drag and drop this created instance in here. It does not show all the information, so we would like to have some we don't need to see available cache column in here, so let me just hide it. We would like to see what types of CPUs have we used in building this instance, so we are going to identify, show us the CPU, and also show its the value property as well. Show us the display, show us its weight, and since we also have certain constraints, we may also like to see what those constraints are telling us about it. So we'll just simply click on the max weight limit constraint so that we can see pass and fail verdicts when the evaluation is done. And we would definitely like to see the total weight of our ATM. So I think that's about it. Let's just, so now you see we have the weight of the total. Since we have not run any simulations or evaluations, you see the total weight to be 0 kg. The third column tells us that we have used CPU 1, so it's the that was the the block that was used to provide us with the instance of a CPU or computer unit. The ATM dot display took the high res display instance in this instance. So what we can do is we can have these things arranged in such a way that we see the CPU weight right next to the type of CPU that we have selected, the display weight right next to it, and then at the end we see the constraint as to whether that constraint was passed or failed by this particular combination that we are trying to build our ATM machine with. So let me just have all of those things, enlarge it a little bit, select this row and run the simulation, and you see that we have the 10 kg of our CPU 1, and we have the 3 kg of the high resolution display, and we have the total weight equal to 13 kg, and this is within the limits of our constraint that we had for the maximum limit, therefore it passed that. Okay, let's have one more instance created so that we see it one more time, and then that would be the conclusion of this particular construction. So let me go back to the BDD, and this time we are going to have another instance by going to tools, create an instance. Let's open all these things up. So we are going to have a CPU, but this time we are going to have CPU 2, and we are going to have its weight, and we are going to select a display. This time we are selecting the low resolution display and checking its weight value as well. And I think we have all those things that we wanted. Let's just finish it. And again, it will show us the, the created instance over here with the selected parts, and we can put this, again, it created it here. We can also bring it in the folder that we have created for instances. Okay, let me see if I can. No, it's not going there because it has the same name. So let me just call it something else. This is ATM1. And now drag it. Okay, now we have it. Going back to the instance tables, drag and drop this new. And you see that this one shows the CPU2 as this computer unit and the low resolution display as the, okay, let me just quickly run my simulations on this new instance that we have created, and it tells you that 6.8 plus 5 kgs, it gives you 11.8, which still passes the constraint. So now we have these two combinations. We can create the other two combinations and evaluate all of those possible combinations, and if all pass, we can just about connect any two things, one CPU and one from the possible two displays that we have, and would have an ATM constructed which would follow at least the constraints that we have in this diagram. Anyway, so that's it. That's about it. So we have looked at three possible ways of assigning these value properties or values of these value properties and evaluating those using parametric diagram. In the first one, we had a user providing it. In the second one, we had them as random variables. And in the last one, we have these specialized blocks which would provide these values, and we would have all possible combinations of these to create those instances, and we'll evaluate those instances against our constraints. Thank you.